Bismillahirrahmanirrahim. Guys, today we will go through our C circuits. We have gone through introduction for this material last week, and today I will be explaining more about the RC circuits. RC circuits, it means a circuit which is including resistor and capacitor, and the combination between that resistor and capacitor will be in series. And the best figure to show that circuit is this one. This is a resistor. It's connected in series with a capacitor, and there is a power supply which could be a battery, and there is a switch. The switch here is something new for our circuits, but always there is a switch in the circuits. But sometimes we just ignore it because we just assume that it is there. But in this material, we are very concerned about the moment when the switch is closed or open, so we need to take the switch into consideration. So it's an easy circuit. It's supposed to be an easy circuit with a resistor and capacitor connected in series. They cannot be connected in parallel. This is the condition of the RC circuit. You can read the title, resistor and capacitor in series. We have two major, if we say, operations inside these circuits. One is the charging of the capacitor, and the other one is the discharging of the capacitor. Okay, so it's the capacitor, it's not the resistor. We are charging or discharging of the capacitor. Let's just get a quick flash, memory flash, about the capacitor. What is the main formula for the capacitor? Our favorite, Q is equal to CV. So this is the charging of the capacitor, the Q. While if we will talk about the resistor, it's Ohm's law, V is equal I times R, and we will be using both of them. But when we say charging and discharging, we are talking about the capacitor. Okay, so this is the capacitor related law, and this is the resistor related formula or law. Okay, now we mentioned last week something. We said that there is a graph for the charging of the capacitor and there is a graph for the discharging of the capacitor. Let me review that concept. Again, what is a Q? It's equal CV, all right? So if we just simply say that I want to graph the charge on the capacitor, okay? If you see here, this is the voltage across the capacitor. You see V sub C. It's not V times C. It's not. It's V sub C. If you will write it, you will write it like this. So this is the voltage across the capacitor. What is the voltage across the capacitor? It is equal to Q divided by C, right? So C and R are given values. For example, the C is 1 microfarad or 10 microfarad or whatever. It is a given value. So if you see voltage across the capacitor, I can say V sub C is directly proportional to the charge across the capacitor. So if I want to graph V, okay, with respect to time, طبعا دايما we always have the x-axis to be time because we are charging, and charging or discharging is going with time. Either if I will say the charge of the capacitor, or if I will say the voltage across the capacitor, to your surprise or not to your surprise, they should have the same looking graph because they are literally directly proportional to each other with a constant 1 over C between them. For example, if the graph looking is like that for this one, the graph should be looking like that. All right? But what is the difference between them? That maximum value. That will be a charge, that will be a voltage. But in general, the looking of the graph for the charge and the voltage across the capacitor is exactly the same. The tendency is the same. All right? Now, if you see, this is time, and we start from time 0. The charge across the capacitor will be 0 because we haven't started charging yet. We will just start charging. So the charge will start from 0 and it will keep charging till it will reach to a saturation level. What is the meaning of saturation? That no matter how long you will keep it charging, it will not charge anymore. And that's we call it the maximum charge that the capacitor will reach, where at the maximum charge, we will reach to the maximum voltage across the capacitor. All right, so the book choose to sketch the graph of the voltage across the capacitor, but I'm telling you they have the same kind of graph. Now, what is the maximum voltage that can be across the capacitor? It is the maximum voltage in that circuit, which is the voltage of the power supply. So this is kind of very important graph to understand. This is a charging graph. It started from 0. The voltage across the capacitor is 0. The charge across the capacitor is 0. We keep going. Forget about these details for at this moment. We keep going and it will be increasing. The charge is increasing. The voltage across the capacitor is increasing till we reach to the maximum value. So maximum charge across the capacitor will also have the maximum voltage across the capacitor. Now let me just tell you why the maximum voltage across the capacitor is equal to the voltage of the power supply, which is epsilon. Because, just listen carefully to my explanation. At the time where we will have maximum charge on the capacitor, the current across the circuit will be stopped moving. There will be no current moving anymore. If there is no current moving, V is equal I times R. So if I is 0, so what is the voltage across the resistor? It is 0 as well, right? If the current will be 0 when we are done with the charging, it means the voltage across the resistor is 0. So all the voltage of the power supply will be up the voltage across the capacitor, because it's as good as we don't have resistor anymore. All right, guys? All right. So the maximum voltage across the capacitor is equal to epsilon. So for example, if you get a graph like that and they will ask you simply, what is the charge, what is the value of the power supply? It's just whatever this maximum point is. Okay, it could, like, you could have a question with a graph like that, and this is the voltage across the capacitor, and there is a number here, let's say 9 or whatever, and they will say, what is the voltage of the battery or the power supply in this circuit? You will have nothing to do other than just read this number, and this will be the voltage of the power supply, which is the maximum voltage across the capacitor in the charging process. All right, so what if I will draw the charge? It's the same graph, except this y-axis will be Q, and the maximum value here will be Q maximum. Who can tell me what is Q maximum? It is V maximum times C. So instead of epsilon, we will have V maximum times C, which is epsilon times C, right? Because it's V maximum times C, which is Q maximum, which is C times epsilon naught. That if it's not the voltage across the capacitor, it's the charge across the capacitor. كمان مرة, we will mention something like it's the charge across the capacitor sub C. It's not Q times C, it's Q sub C. Great, so this is the charging process, and we discussed the voltage and the charge across the capacitor. Great. There is something, before I will go into time constant and these things, I will go through the current across the circuit. When we close the switch, maximum current will be produced by, or basically this is electromotive force, it will push the current to, or the charges to move, so maximum current will be produced in the circuit. Now, if the voltage across the capacitor or the charge at the beginning is zero, so voltage is zero, so what is the voltage that we have here? It is V is equal I times R. So the moment we switch, we close the switch, so the circuit will be going on, maximum current will be produced. The maximum current will be produced. And that maximum current will be the voltage across the resistor divided by that resistor value. What is the voltage across the resistor at that moment? It is the voltage of the power supply. It's the maximum divided by R. So the maximum current happens when we just close the switch, because there is nothing going on here. We don't have charge yet, so it's as good as we don't have the capacitor. But of course it's connected, so we have a closed circuit. So the maximum current will be, it's as good as we have only this circuit. But I don't want to do that because we really have other things. But just imagine that this is the maximum value E and the current, so it is V is equal I times R. At the moment where we close the circuit, the capacitor, as if it's not there, because there is no charge, so there is no voltage drop due to the capacitor. So I maximum, I am writing it again, is equal the maximum voltage divided by the resistor. The interesting thing that the current starts maximum and then it decreases till the fully charged happen. We don't have current running in the circuit anymore. I will repeat that point. Once we close the switch, maximum current will be going on, all right, and it will be going on till this capacitor will be fully charged. Once it's fully charged, there is no current running in the circuit. No matter how long you will keep it, for example, on charging, there will be no more charging anymore. There will be no current flowing in the circuit anymore. So the current starts from maximum, which is epsilon divided by R. This is Ohm's law again. Okay, and this is the power supply. So this is the maximum current. So this is equal I maximum. Okay, this is equal V maximum, or this is equal Q maximum. These are important, if we say important points to take care of in these kind of graphs. So this is I maximum, which is epsilon over R. You see, the charge and the voltage start from zero to be zero, and then they increase. But the current start from maximum, and then it will decrease till it will reach almost zero. You know, when we say almost, that is the asymptotes. The asymptotes. If you remember in math, that they come very close to the zero, but it doesn't literally become zero, but we can say that at the end there is no current. We can say it's approximately zero. All right, guys. The equation which describe this graph, it's from experimental point of view, it is given by this exponential term. And the same equation is given for the charge across the capacitor. All right, so this is the voltage across the capacitor, this is the charge across the capacitor, and this is the equation of the current across the capacitor. All right, I will continue about that in the second YouTube.